Today we will discuss about the atoms and molecules. Matter can be divided physically and chemically. Physically into the solid, liquid and gaseous state, and chemically into the elements, compounds and mixture. Laws of chemical combination. Laws of chemical combinations are two laws are here: law of conservation of mass and law of constant proportions. Law of conservation of mass. Conservation of mass means mass cannot be destroyed. It states that mass can neither be created nor be destroyed in a chemical reaction. This law is also known as the law of indestructibility of the matter. Law of constant proportions. It is also known as the law of definite composition. This law states that in a chemical substance, the elements are always present in the definite proportion. Because this is the law of constant or definite proportion, the substance in a chemical substance, the elements are always present in the definite proportion by mass. In a compound such as water, the ratio of mass of hydrogen to mass of the oxygen is always 1:8, whatever the source of the water. If 9 gram of the water is decomposed, then it will give 1 gram of hydrogen and 8 gram of oxygen. Atomic theory. According to the Dalton atomic theory, all matters, whether an element, compound or mixture, is composed of the small particle called the atoms. About the main postulates of Dalton atomic theory. All matter is made up of very tiny particles called the atoms. Dalton said that all matter made up of the very tiny particles, and these tiny particles are called atoms. Atoms are indivisible particles. Dalton said that atoms are indivisible particles which cannot be created or destroyed in a chemical reaction. Atoms of the given element are identical. If we break the iron rod, then even smallest portion consists of the atom of the iron. Atoms of the given element are identical in mass and chemical properties. Atoms of the different element have different masses. If we take the hydrogen and oxygen, then both the element have different masses and chemical properties also different. Atoms combine in the ratio of small whole numbers to form compounds. When we form the compound, we look that these elements are always in the whole number, not in the fraction. We can say at H is equal to 2.5, oxygen is equal to 16.5. No, this will be in the small whole number. The relative number and kinds of atom are constant in a given compound. The drawbacks of the Dalton atomic theory. Atom has been found to be made up of the subatomic particles electrons, protons and neutrons, but Dalton said that atom is indivisible. It cannot be divided into small particles. Atom of the same element may have different masses, just like in the isotopes. We can see that in the isotopes of hydrogen, protium, deuterium, tritium. Atoms of the same element may have different mass. Atom of the different element may have same mass, just in the isobar. Argon and calcium, we can see in the example of argon and calcium. Atom of the different element may not always combine in the simple whole number ratio to form molecule of the compound. These were the drawbacks of the Dalton atomic theory. Write the chemical formula. Chemical formula of a compound is the symbolic representation of its composition. Mean it is write down in the form of symbols. For writing chemical formula, we need to learn symbols and combining capacity of the elements. Combining capacity of element is known as the valency. Combining capacity of element is known as valency. Valency can be used to find how the atom of an element will combine with the atom of another element to form a chemical compound. Now, what are the rules to write a chemical formula? Rules used to follow while writing a chemical formula are: write down the symbol of the compound. First, write down the symbol. If you write down the sodium chloride formula, then first write down the symbol sodium Na chloride Cl. Write down the symbol of the compound element present in the compound. When a compound consists of the metal and a non-metal, the name or symbol of metal is written first. In NaCl, we will write down the Na first. Na is metal and it will be right on the left hand side and chlorine on the right hand side. The valencies or charge on the ion must balance. The valencies or charge on the ion must balance. In compounds formed with polyatomic ions, ions enclosed in the brackets before writing the number to indicate the ratio. If we want to write the aluminium sulfate, it is a polyatomic ion 4 and 1 5. 5 atomicity is there. It is pentatomicity compound and we will write in the bracket and then indicate the number. In case the number of polyatomic ion, if the polyatomic ion is 1, the brackets is not required, just like NaOH. NaOH, we can write down the NaOH directly, not write down this, just no need to indicate 1 valency. If we want to write down the chemical formula, then first we should learn these 20 elements name, symbol and atomic number and mass number. First you will learn these 20 elements: hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium and calcium. Now symbol. Symbol for hydrogen is H. Helium. If we write down H here, then both the hydrogen and helium symbol mix, then E is there in the form of the symbol. Lithium Li, beryllium Be, boron B, carbon C, nitrogen N, oxygen O, fluorine F, neon Ne. Sodium is different symbol Na, not taken from the names Na. Magnesium Mg, aluminium Al, silicon Si, phosphorus P, sulfur S, chlorine Cl, argon Ar, potassium K. Potassium is also different symbol. Potassium is K. Calcium is Ca. Now this on the lower side, this is the atomic number, and on the upper side this is the mass number, and it is near about the double. Hydrogen 1, and in the sum numerical you will see 2 and you will see 1. Helium is 2 and 4. Lithium at the number 3, atomic number is 3, mass number is 6. Beryllium, atomic number 4, mass number 8. Boron 5, 10. Carbon 6, 12. Nitrogen 7, 14. Oxygen 8, 16. Fluorine 9, 18. Neon 10, 20. Sodium have different atomic number and different mass number. 11, it should be 22, but it is not 22, it is 23. Instead of 22, it is 23. Magnesium 12, 24. Aluminium 13, 27. Aluminium is used 27. Silicon 14, 28. Phosphorus 15, 30. Sulfur 16, 32. Chlorine is also different, 17. It should be 34, but it is not 34. Actually 35.5 is the mass number, but in the numerical you can use 35. Argon 1836 and potassium is also different, 1939, and calcium is 20 and 40. Polyatomic ion. Polyatomic ion, you will learn these polyatomic ion. These are very necessary for the numericals. Ammonium hydroxide. For ammonium, NH4 plus only plus mean it is 1. OH minus 1. 1. Hydroxide OH. Nitrate NO3 minus 1. Hydrogen carbonate HCO3 minus 1. Carbonate CO3 2 minus. Sulfite SO3 2 minus. Sulfate SO4 2 minus. Phosphate PO4 3 minus. These are the valencies. These are the valencies. Now, non-metallic element. Oxides O2 minus, sulfide S2 minus, nitride and 3 minus. We will do the practice of formula writing. Formula of simple compound or binary compound. The simplest compound which are made up of two different elements are called binary compound. Just like Na and Cl. These are the two elements. This is called binary compound. Now write down the formula of hydrogen chloride. Write down the hydrogen and chloride first. First write down, separate it, hydrogen and chloride. Now write down the symbol first. Hydrogen symbol is H and chloride symbol is Cl. And hydrogen is at the 1. Atomic number is 1 and its mass number is 1. Then its valency is 1 and chlorine is at the 17 and its atomic mass number is 35 and chlorine atomic number is 17 and its electronic configuration is 287. It can gain 1 electron. Hence its valency or combining capacity is -1. Now write down the symbol here and write down their valency below them. Hydrogen has 1 valency, write 1. Chlorine has 1 valency, write then 1. Then cross multiply. Cross multiply H1Cl1. No need to write 1 1. It is already understood. HCl. It means 1 1 HCl. Formula is hydrogen chloride. Now we will write down for the hydrogen sulfide. Hydrogen sulfide. Write down the symbol first. For the hydrogen, symbol H, sulfide symbol S. For the hydrogen, atomic number is 1, then its valency is 1 and sulfide it is at the 16 and its valency is 2, S2 minus 1. Now write down the valency. Hydrogen 1, sulfur 2. Now cross multiply H2 and S1. This is the formula of hydrogen sulfide. Now we will take the example of carbon tetrachloride. First write down the element name carbon and then symbol C and chloride Cl. Now carbon valency is C4 because it is at the 6, atomic number is 6 and electronic configuration become 2 4. It need 4 electron to complete its octet. Then its valency is 4 and chloride 17 and 287. It will gain 1 electron. It will gain 1 electron. Its valency is 1. Now write down C4Cl1. Now cross multiply this. Now C1 and Cl4. This is carbon tetrachloride. Tetra means 4. 4 chlorine is there. Now magnesium chloride. Magnesium chloride. Write down the name of the element and symbol. Magnesium and chlorine. Magnesium valency is 2 plus and chlorine valency is -1. Now write down magnesium 2, chlorine 1 valency, then cross multiply and it will become Mg1 and Cl2. Now next, aluminium oxide. First write down the element name and symbol. Aluminium Al, oxide O. Now write down the valency. Aluminium 3 plus and oxygen 2 minus. Now write down the valency. Aluminium 3, oxygen 2. Now cross multiply and write down Al2O3. This is aluminium oxide. Now calcium hydroxide. Calcium symbol is Ca, hydroxide symbol is OH and calcium valency is 2 plus and hydroxide valency is -1. Now write down Ca2OH1 and write down CaOH2. Write down in this way. If you write CaOH2, then it will be wrong. It will be wrong because OH2 means only H has 2 atoms, not oxygen. Not oxygen. So first mark the bracket and then only write down the number. What is atom? Atom is the smallest particle of the matter which can take part in a chemical reaction and it cannot exist independently. It is the smallest part of the matter that take part in the chemical reaction. Symbol. The shortened name of the element. The shortened name of the element are known as the symbol. Atomic mass unit. It is defined as the mass of 1/12 of the mass of the one atom of carbon taken as 12. For example, atomic mass of oxygen is 16 U. This means that an atom of oxygen is 16 times heavier. An atom of the oxygen is 16 times heavier than the 1/12 of mass of carbon atom taken as 1 U. Atomic mass of oxygen is equal to 16 into 1/12 of atomic mass of carbon is 1/12 of atomic mass of carbon is 12. Cut 12 with the 12, then atomic mass of oxygen is 16U. Now, what is the molecule? Molecule of an element are formed by the combination of two or more atoms of the same element or different element. Molecule is formed by the combination of the two or more atoms of the same element. The number of atoms present in the molecule of an element represents its atomicity. Atomicity, which tells the number of the atom in a molecule. For example, H2, H plus H. It means there are one atom of hydrogen and one atom of hydrogen. It becomes H2. Then the atomicity of hydrogen is 2. Atomicity of hydrogen is 2. If it is in the same atom, then it is called homoatomicity. O3. O3 means 3O combined together and it means 3 atoms of the oxygen is present in it. Then atomicity of the O3 is 3. P4. P, write down 4 times. It means 4 atoms of the phosphorus is present in it. Then its atomicity is 4. HCl. 1 atom H and 1 atom Cl. It means it is diatomic. It is diatomic but heteroatomic, not homoatomic. It is heteroatomic. H2O. H 2 times and oxygen 1 time. 1 atom of hydrogen, 1 atom of hydrogen, 1 atom of oxygen. 1 atom of hydrogen form the molecule of hydrogen. Then it is triatomic. NH3, 1 nitrogen, 3 hydrogen. It means 4. It is called tetraatomicity. 4 atomicity is there. 4 means tetraatomicity. CH4, 4 plus 1 carbon, 5. Pentaatomicity is there. These are the heteroatom. Ions. Ion is defined as the atom or group of the atom having positive or negative charge. Positive charge ion called the cation. Sodium, potassium, calcium, aluminium, all these carry the positive charge and these are all the cations. Negatively charged ions are called anions. Chlorine, sulfide, hydroxide, sulfate, all these carries negative charge. These are the anions. Students, today we will discuss about the molecular mass. It is the sum of the atomic mass of all the atoms in a molecule of the substance. Molecular mass is the sum of atomic masses. It is the total sum of the atomic masses of all the atoms in a molecule of a substance. And it is expressed in U. For example, if we want to calculate the molecular mass of water, water is H2O. First write down the formula H2O. Now atomic mass of hydrogen. H2O consists of hydrogen and oxygen. Atomic mass of hydrogen is 1 U. Atomic mass of oxygen is 16 U. And when we count molecular mass of water, then hydrogen one atomic mass multiplied with 2 because here the 2 atom of hydrogen is present, plus oxygen 1 atom. There is no number, it means only 1 atom is present of the oxygen. 1 atom of oxygen multiplied with the atomic mass of oxygen. 2 into 1 2 plus 16 into 1 16, 16 plus 2 is 18 U. This is the molecular mass of the water, because water is the molecule and its mass is called the molecular mass. Now HNO3. H, hydrogen, 1 atom is present and its atomic number is 1. Nitrogen, 1 atom is present and its atomic number is 14. Atomic mass is 14 and oxygen atom is 3. O3. O3 means 3 oxygen atom and atomic mass of oxygen is 16. 1 into 1, 1, 1 into 14, 14 and 16 into 3 is 48. And this will become 63U. 63U. HNO3 molecular mass is 63U. Now the formula unit mass. It is the sum of the atomic mass of all the atoms in a formula unit of a compound. When we count the molecular mass, first we will write the formula. If we write the formula and find out the mass, then this is also the same. This is the formula, mass of the formula. This and this both are the same. It is used for the ions. Only difference is this. It is used for the ions. For example, NaCl. If we count the NaCl, first write down the symbol, then Na is 1, Cl is 1, mean 1 atom of the sodium, 1 atom of the chlorine, then 1 atom of sodium multiplied with the atomic mass of sodium, that is 23, and atomic mass of chlorine, that is 35.5. Now combine with both of these and it will become 58.5 U. Now CaCl2. We can take the example of CaCl2. Ca, calcium. Ca, 1 atom is present there, and Cl2. 2 means 2 atom is present there, and its atomic mass is 40, and chlorine atomic mass is 35.5, and then it becomes 40 into 1 40, 35.5 into 2 equal to 71, and the total formula unit mass will become 111 U. Now what is the molar mass? Molar mass. Molar mass is also the sum of the atomic masses of the element. If you count the Cl2, if you calculate the Cl2 molar mass, then Cl, chlorine, is atomic mass is 35.5, and here 2 atom of chlorine is present, then multiplied with 2, and then its molar mass is 71 U. CO2. CO2 atom is 1 and oxygen atom is 2, then atomic mass of the carbon is 12 and atomic mass of oxygen is 16. Now multiply this, 12 into 1 12, 16 into 2 32, and the total molar mass of the CO2 is 44 U. Concept. Mole is the measurement in chemistry. It is the measurement unit. It is used to express the amount of the chemical substance. It will tell the amount of the substance present in any compound. Mole is the SI unit for the amount of the substance. Now what is 1 mole? 1 mole is defined as the amount of substance. It is the amount of substance of a system which contains as many entities like atom, molecule and ion, as there are atoms in the 12 gram of carbon 12. Avogadro number. The number of particles present in 1 mole of any substance is equal to 6.022 into 10 raised to power 23. This is called Avogadro number or Avogadro constant. 1 mole of hydrogen atom represents 6.022 into 10 raised to power 23 hydrogen atom. 1 mole of any substance has a mass equal to its molar mass, which is the sum of atomic masses of the constituent atom. The mole concepts provide a way to quantify the substance in terms of both mass and number of the particle. It will count the mass as well as number of the particles, whether atom, molecules or ion. Just as a dozen. Dozen means 12. When you count dozen, it means there is the thing which is 12 in number. And a mole means its amount is 6.022 multiplies 10 raised to power 23 particles. This allows chemists to easily count the vast number of tiny particles. Chemists can count the number of atoms, number of molecules and number of ions in a sample. Number of moles is equal to weight of the substance by molar mass. Number of moles represented by the N and weight of the substance represented by the small m and molar mass by capital M. If we want to count the number of atom, then formula is number of atom is equal to given mass by molar mass into Avogadro number. Number of atom is N and given mass is small m and molar mass is capital M and Avogadro number is N0. If we count the number of atom, molecules, ion, particles, then the formula will be N is equal to small m by capital M into N0, where N0 is the Avogadro number and Avogadro number is 6.022 into 10 raised to power 23. This is the mole concept. Thank you.